Hey guys, welcome back to Science. Today we are talking about convection. Last lesson we talked about how heat moves through solids, so what you end up having are the particles really close together in a solid. They end up bumping into each other and sharing all of their energy. That doesn't work as well in a liquid, and so in a liquid we're going to talk today about convection. So what we have here is a fish tank filled with lukewarm water, Erlenmeyer flask with some green food coloring in there, a stopper with, I'm not sure if you can see, 2 holes, one with a glass tube, the other one without, just to allow water to go in and out of the flask, and hot water. So what we're going to do is fill up our flask. And what we're going to do is we're going to place it into the fish tank. Let's roll up the sleeves so they don't get wet. Place it into the fish tank. Make sure that's on there good. And what you can see is a steady stream of the warm water floating to the top. Now, some of it will end up mixing with the rest of the water, but what you'll notice is that it's mostly just sitting at the top. So what ends up happening is, as the particles get warm, we remember that the particles end up expanding or getting further and further apart because the energy is giving them more and more motion. So they're becoming less dense. So what ends up happening is, because they're less dense, they end up floating, just like oil sits on top of water. So you'll notice even now it's spreading all the way across the top and it's actually not sinking back down. So in a liquid, this is how it works. So when you're boiling water, the heat from the bottom of your element is heating up the bottom of your pot, heating up the water, and then what ends up happening is it actually cycles through and it'll actually create a current. Now, in this one, we're noticing we're just having one hot spot over here. All the warmth is spreading across the top. Now I'm going to speed this up a little bit. We're going to add one more flask just of hot water. Once again with food coloring. And I'm actually just going to pour this just gently. And you'll notice it's actually not mixing with the rest of the water. What it's doing is coming and sitting right at the top. So we're getting a nice green cloud right at the top. What ends up happening? Hot water, less dense, floats to the top. So when water or warm liquids will end up rising up, now what we're going to do is I'm going to take this ice bath and I'm actually going to place it just on the surface here. So what we're going to see happening now is all of the particles that come in contact with the ice bath are going to get colder, meaning the particles are going to get closer and closer together. This means that they're going to become more dense or heavier for their size, and because of that, they are going to start to sink because they're going to be colder than all of the particles around them. And if we look closer here, what we're going to see is small streaks of the green water starting to come down. So once again, they're cooling off and they're going to sink down to the bottom. Is as the warm green particles in the water end up coming in contact with the cold beaker, they cool down and they become less dense. So they actually start to sink, and it's just in that area. The rest of it will eventually mix once the entire thing comes to the same temperature, but at that moment, so this is how a cycle happens. So you end up getting warm, in this case liquid, rises up to the top. As it gets cooled, it ends up sinking, and it'll actually create a cycle where it ends up going around. So this is called a convection current. Now you'll notice actually here, it still has a small stream coming out the top, but it's very minimal. Now the reason for that is there is some of the lukewarm water going into the beaker and actually cooling everything off in there, so that water's not as hot anymore, so it's not able to rise as fast. So the cooler you are able to have it, or the faster it'll go down, the warmer you have it, the faster it will go up. Try not to disrupt the water too much. And you can see where I place the ice cubes, the green water is going down at a faster rate. So once again, just because the temperature is significantly colder, it cools it down, it becomes more dense, and it actually becomes heavier than the room temperature water, and so it's going to sink all the way down to the bottom. What would happen is it will eventually fill up the entire bottom, and we'll actually have a gap in the middle. So I'm going to see if we add a large amount of ice cubes, if we can actually get a layer on the bottom and a layer on the top. Of green with a clear section in the middle. So this area will be significantly colder than the rest of the water, and so we should get a nice cool layer. To just sit right on the bottom. So as the green water on the top gets cooled down and comes to the bottom, you'll see there's a large amount of it that's actually going down because it's cooling down so fast. If you watch the top, you can actually see the top getting sucked over towards the ice cubes, so creating that current we had talked about earlier. All right, now that was a little bit slow, so let's rewind that and watch it a little bit sped up. And you'll notice that because this side is so cool, actually there's almost no green left over here. And the reason for that is all of the water is actually coming this way, because as this water comes down, it actually pulls water from over here. And so now we're filling up the bottom half again. All right, boys and girls, that's all your time with Mr. Weens for today. Talk to you next time.